without further ado, hopefully you have now all refreshed your coffee, tea, maybe gone and got that bit of chocolate to get you through the last part of the TechCast day. I don't know which one you're on. I'm personally going to be digging into a little bit of chocolate and tea as we invite Mr. Jeroen to join us from Oracle. This man's an amazing person. If you want to listen to more of him, he does the voiceovers on the hands-on learning labs. It's great, a great way to learn more, and he has so much knowledge and information to give us on the Oracle Cloud. Jeroen, today we are looking at my favorite subject. You know I'm a football fan or a soccer fan, so we are going to have so much fun looking at machine learning and expected goals. I'm going to be making notes here on how my team can definitely improve. So yeah, over to you, my friend. Really looking forward to this one.
Thank you so much, Abby. That's a great introduction. Oh, I really hope you can. Your team, it's a female soccer team, no? That you're
correct. I coach a women's football team here in England. So those who don't know, I did a presentation on football analytics a while back, slightly different to Jeroen, but using that to encourage grassroots community football and get young girls and women into analytics and sports analytics. So we've ended up with a little group of us who now do Python coding for football analytics, and all born from
awesome.
a little project I did during pandemic lockdown time. So yeah, we've got now a little hub of coders who also play football. Who knew?
Right. Who would have expected that, right? So that's amazing. Okay, well, let's see if expected goals can help you or your team. Well, we're gonna find out.
We're gonna find out, definitely. Do you want to see if you can share your screen, my friend?
Let me see. Yeah, of course. I need to steal that from you first. So, see. I think that should be coming through, right? Yeah.
Perfect. You are good to go, my friend.
Okay. Yeah. So we are going to talk about the Premier League, which is the highest English football league. And as I mentioned already, expected goals is the concept we're going to talk about, which is a way of understanding football. And I'm going to dive into all the details behind that. But I'd really like to know first from the audience if we have any other football fans apart from Abby in the audience. Do you have a favorite team? Do you follow the Premier League or just the Major League in the US? Maybe you can put it in the Zoom chat. Let's see if we can get some team names in there, or maybe you have a national team that you follow. I'd really like to know that. And so then I'm going to start with this. Yeah, let's say it's a data story. You may not know that Oracle is actually the technology partner of the Premier League. And that means we're not just a sponsor, we're actually getting in there with the technology and also having an impact on the games because of that. Because nowadays, if you look at a broadcast of the Premier League, for example, the fans can see insights from the game, like metrics that help them understand the game better. But I'd like to talk to you about a different thing. I'd like to take the perspective of teams and of coaches and see how they can use data to find out what are the good points about their team, but maybe also some things where they could be improving and even making some decisions that help their gameplay. So we now have about 40 minutes, but there's also, of everything you see, there's a full hands-on workshop. So if you like what you see in this session, you can spend 3 hours. This is available on demand on this link. We ran this a couple of months ago, and all the data is there. There's videos explaining everything. You learn how to work with machine learning in the context of football and the Premier League, and everything is self-contained. So you can just go here and try this out. Okay, so the stars of this session are Manchester City. They are the team that won the Premier League last year. They're very excited here. They just got the prize. Of course, they're ecstatic. And this man, Pep Guardiola, he's also really happy, of course, with that, with winning last year. but he's already, of course, thinking also about, well, the season that actually already started. He, as the brain behind the team, he needs to think about, yeah, what are the very good points of the team, but also what are not such good things, where could they be improving? And what we're going to do in this session is just to see how the database, how the in-database machine learning, and also analytics can help Mr. Guardiola doing exactly that. So expected goals, what is that? It's also called XG. It's a concept that's been around for a few years now in football. As I mentioned, it's getting more and more important. Like, yeah, one of the best ways of understanding what's going on in the game. And if you want to analyze football, you may say, oh, let's look at the goals, right? But the problem with goals is there's only so few of them. Right? You have about 2 or 3 on any game on average. And that just gives you not so much data to work with. So what expected goals is, it actually is about shots. So chances of scoring a goal. And shots, of course, we have a lot more. So we have more data to work with. We're going to look at the quality kind of those shots. So we're going to, expected goals really means what is the chance that a certain shot will become a goal, right? And if we work with that metric, it turns out that we can understand things so much better, the player performance, also the whole team performance, offensive side, defensive side. So let's just take an example here. That's one step too far. Oh, there we go. So this is Mo Salah. He plays for Liverpool, the runner-ups of last year. So they came second. He's about to take a shot here. And you see this value on the bottom left of 0.06. That's the value, the expected goals value that comes from a machine learning model. And that basically means that this model expects the player to score this shot in only 6% of the cases. So, and that's taken into the consideration, let's say the distance from the goal, the angle to the goal, and even things like where the defensive players are. So let's see how Mo works with those odds. Yeah, so fantastic goal by Mo. And even from just a 6% chance, he scores. And an important thing to understand is that this expected goals model, it gives the output for the average player. So it doesn't take into account that Mo is like a spectacular finisher, okay? And in fact, he scored here what fans called the goal of the season. So it was awarded as the goal of the season. So this XG number, I said already, it comes from a machine learning model. That model's been trained on thousands of shots in the past, so multiple seasons of data. It looks at all kinds of variables around each shot. So what was the distance that the player was when he took the shot from the goal? What body part did he use? Was it a kick? Was it a header? What was the kind of playing situation? What kind of pass did he receive, etc., etc.? And this model learns to recognize with what kind of percentage each kind of shot situation typically leads to a goal. Once you have that model, we can do what we just did, right? So we can look at one particular shot, like the one by Mo, and we can say, what's the chance that he scores this shot? But it's much more interesting, actually, when we look at many shots. So, for example, the expected goals values for all of the shots of a player in a certain season. That's where it gets really interesting, and we can get the kind of insights that are kind of hidden normally for us. So we're going to see all of that. We're going to build this all up, okay? So what I'm going to demonstrate is basically a two-step process. We're first going to build that model, and for that we've got data from the Premier League, especially for the occasion. That's kind of the benefit of this technology partnership. So we're going to start from the data, build the model, and then once we have the model, use it to get those insights and to see where Manchester City could be improving things. So we're going to start right there. And for that, I'm going to open analytics. So let me just go right here. And we want to build that model. So what data do we even have available for building that model? Here we're looking at what's called the event data set, but really that just means shots. So there are thousands of shots in this data set. What do we know about these shots? Well, for example, did the shot become a goal? Right? You can imagine we want to predict, will a shot become a goal? So obviously, this is the first thing we need to know, right? Does it become a goal? And most of the shots obviously don't become goals. What else do we know? We know, for example, the X and Y position of the player when he took the shot. That's really important because we can calculate things from it, like the distance. Now, to me, it seems, very likely that distance is a candidate, right, that has some predictive power or some predictive relevance for saying if a shot becomes a goal. But we're going to find out. We're going to see that later on. And then there's all of this describing data. So what else do we know about the shot? Like the body part that was used. Let me see. That was a little bit further back here. Yeah, was it a header? What foot was used? Another body part? What was the playing situation? Was it a counter kind of situation? Was it a free kick, a corner? You name it. And like this, there are, I believe, about 50 variables more. And now, the big question, of course, is, and the challenge is, which ones of these data points are even relevant, right? So we want a model that predicts the chance of scoring from this shot in this situation. How do we know which ones of these to actually select for a model training? And that is actually the same as asking which ones of these variables influences the chance of scoring, right? Because those are the ones I want to include, right? To train my model on. Now, how can we find out if there is such a relationship? Well, one way to do that is to use visualizations. So we're just going to do a few of those. So I can show you that process. So we're first going to take like a helicopter view from the football field. So let me just open that here. Yeah, so again, we've got thousands of shots here, kind of summarized into one visualization. And the color here indicates the scoring chance. And that's simply the number of goals from a certain position divided by the number of shots from that same position. So if you take, let's see here, very close to the goal, for example, here, event count of 9, that's the number of shots, 9 shots, and 89% of those actually became goals. That is really high. But of course, the challenge is to get so close to the goal in the first place. That's not easy, but it's a good place to be as an attacker. If you then move away a bit further from the goal, the score percentage drops really quickly, right? So here it's already down to like 8% or 0.08. And you go a bit further out and it goes to like 1% or almost 0, right? So you see how much this distance indeed influences the chance of scoring, which I don't think is really surprising, but we see that confirmed here. So what else can we learn from this picture? Well, I noticed here by the side of the goal, you see that here, kind of this triangular area near the goal line, and then the same on the other side. Notice how there's like very few shots from those positions and even fewer goals, right? There's like a score percentage of 0. And that makes a lot of sense to me because from there, imagine you're the player, you can hardly see the goal, right? You don't even see the opening of the goal from there because you're just too close to the goal line, to the back of the field. So the angle to the goal also is important, right? Now that makes a lot of sense, but we don't have angle yet in the data set. So we just make a mental note for now that we want to extract the angle, and we can do that because we have the position of the shot. So we're going to do that a little bit later on. Now, you may also notice these things here, right? So there's kind of these outliers, these anomalies seemingly a bit further away from the goal. And it appears that those are good places to try to take a shot from because, it's orange. So apparently there's a good chance of scoring from there. What's going on? Well, the answer is in the amount of shots in those positions. So have a look at this one. This one has event count of 1 from this particular, let's say, cell. So only 1 shot was fired from this position on the pitch in multiple seasons of shot data. And that shot just happened to become a goal. So yeah, 100% scoring percentage. Well, let's have a look actually at this shot, because I've got video material of that. So let's have a look at that. And this is a shot by Rooney. You can see he's indeed behind the middle line, really far away. So yeah, small mistake there by the keeper, and then this result, right? Very good finish. So what does this tell us, right? So what do we have to do with these outliers here? Because again, the visualization seems to tell us this is like some kind of sweet spot, or we should take the shots from this position. But we have to keep in mind not just to trust the picture, because the reason here is just the lack of data, basically. When we get a little bit further away, players don't even try to take shots from further away, right? And that leads to a little bit of noise around the edges. So we have to keep using our common sense there. Okay, so we want to select distance to train our model on. We also want the angle, what we need to extract the angle. Those are pretty obvious, I think, but what are not so obvious factors? So I thought, for example, that corners, the fact whether a shot comes from a corner or not from a corner, could be of some kind of influence. So I wanted to check that, and I created this graph for that. So what we see here is, again, multiple seasons of shot data. And on the horizontal axis here, we see the distance of the shot to the goal, right? On the vertical axis here, we have, again, that score percentage. So what is the chance of scoring given a certain distance? And we've divided that. Now I'd like you to have a look at the lines. So the black line here is the scoring percentage per distance for the non-corners, right? So it didn't come from a corner situation, the shot. And the yellow one is where it does come from a corner situation. So notice how this yellow line is like, consistently lower than the black line. And so this is causing a clear pattern, right? Apparently it's more difficult to score a shot from a corner situation. Well, you can think of different reasons. Maybe the defense is more compact, right? Everybody's already in place. But the point is, for us, we want to decide, is this variable useful to predict this chance of scoring a goal? And yes, it is, right? We see that it's clearly causing a pattern. It's clearly influencing the chance of scoring. So we want to select it to train our model on. Okay, so that's how we can go through this process and select the right variables. Now let's just do one more to kind of drive this process home a bit more. So now we're looking at counters, and that's called fast breaks here. So the counter is when the opponent suddenly takes control of the ball and then goes to the other side very quickly, trying to make a shot before all the defense is in place. And so what is the influence of that on the chance of scoring? Well, again, we've divided that in yellow, the counter situations, and in black, the non-counter situations. So you see here that the chance of scoring is apparently higher for the counter situation. But it's, again, a clear pattern, right? It's a clear influencer. And again, we want to include this for our model training. So that's our first step. We're kind of making a selection of our data, the data points that we want to use. And now we get to the actual machine learning. So we're going to exit a little bit now from analytics, and we're going to go to the in-database machine learning. Okay, so now we can work with in-database machine learning in different ways. We can use Python as a programming interface. There's also an AutoML interface. That's no coding, so that's very good for example, business users, right, that don't know about coding. But we are using, in this case, the SQL or the PL/SQL kind of programming interface. And the first thing has nothing really to do with machine learning yet. The first thing is just data preparation. We want to extract that angle that I talked about. So we have the player position when he took the shot. That's the X and the Y coordinate. And from that, we calculate the angle to the goal. And we can use the built-in SQL functions in the database. In this case, some trigonometry functions. It's using the tangent to do that. And yeah, from this, we get the angle to the goal. I think it's amazing that we have all of those functions here, even trigonometry functions. And that's just really convenient, right? Because I don't have to leave the database environment. I don't have to start another program or extract and import data, whatever. I can just do it here, and it's very just convenient. So we've done the first step. Then I'm just preparing this, let's say, second data set, but now only with those pieces of data that we've just selected. So we wanted the distance. We calculated the angle, we put that in there, the counters, the corners, and then a few more. We all put them in there, and they're ready for training now. Okay, so we can go to the training now, but first, before we do that, there's just one more thing I want to talk about, which is a little bit tricky. And for that, I just need to explain one more thing. So let's say if you want to build a machine learning model in general, what we always try to do is to take the data that we have, in this case of existing shots, and to try to fit a function in there. And once you have the function, you can use that for predictions, okay? So let's say we do that, and we only do that based on angle, right? So we have now the angle of the shot. Let's just plot some existing data in a chart and see how that looks. So here on this bottom line here, we see all of those shots that didn't become goals, right? Value of 0. On the let's say the top line, we see all the shots that did become goals. And the angle here is on the horizontal axis. So you see that with an angle as close to 180 as possible, that's like straight in front of the goal, like you're right in the middle and very close, you have a high chance of scoring, right? Because there are the more goals being scored, the higher that angle becomes. And also here at an angle near 0, that means that you're either very far away from the goal, or you're very much to the side. So you're near the goal line, but not in front of the goal, okay? So we see these two cases plotted. A shot can either become a goal or it doesn't, right? So there's nothing in between. But the question is, how do we plot a line here? Because we want our model to not give us a discrete value. We're not so interested, will the shot become a goal or not? We want to know the chance that it becomes a shot, right? We want to know that factor. So my first thought is, okay, that's regression, for example, linear regression. What would happen if we plot like a straight line with linear regression? Well, you could get something like this. And this is trying to fit a function, but it doesn't work very well. So you see most of the existing points are not even near this line. So it doesn't really work. And you get this weird situation that, imagine you've trained this model and you have a shot really close to the goal. So let's say it's 178 degrees to the goal. And you ask that model, what's the chance of scoring? It will give you a factor of something like 1.2 or 120%. Doesn't really make sense, right? You can't have a chance larger than 1. So this doesn't really work. And instead, what we need to use is logistic regression. So logistic regression plots a curve over the existing data. And you see that this fits much better, right? Here, it's very close to those shots that don't become goals. And here, it's close to the ones that do become goals. And this is always a curve, as I said. The angle is different depending on the data, but it's always a curve. And it's always between 0 and 1. So we can never have that weird situation that we predict, oh, this will be a chance of minus 0.2, right? That it becomes a goal. Now, the only thing is, if you go into Oracle Machine Learning, you want to use logistic regression, that's for a classifier. And the classifier, it basically only can return very distinct classes. So a classifier can tell me, yes, this will become a goal. sorry, or it doesn't become a goal. There's nothing in between. So how are we going to do that, right? Because we are interested in the value of the curve, right? In the percentage chance that it becomes a goal. So keep this in mind. It's now all going to make sense when we go back to the notebook. Okay, so we're back in the notebook. Now we're actually going to build our model. Okay, so we can do that with this one call here. And so you see here, we're going to call this model the XG model, just a name, and it's a classifier, right? So again, it seems that thing can only predict, yes, it will become a goal. No, it won't become a goal. But the trick comes a little bit later, because now what we're going to do is we're going to take all of the shots that we have. So we've got a model, right? The training has been done. I've done that earlier today. Now we want to apply that to all of the shots that we already have of like a whole season. And now we can ask that model, okay, I've got this data here for this shot. Tell me how likely tell me, will this shot likely become a goal? Yes or no? That's what this thing does for us, okay? This prediction, yeah, is it clause? I think, yeah, clause is the right word for it. That tells us yes or no. And if we want the percentage chance of scoring that goal, we can use prediction probability. So now we're actually using, let's say, the internal value of that curve inside of the model. Okay, so now, after this, we have basically enriched all of our shots in our data set for a whole season, and it has an XG value. So for each shot, now we know what was the chance of scoring that shot. I hope that all makes sense to you. That's now all in the database. And now we get to the second step. We get to the actual, the insights. Let me just, sorry, just trying to open my PowerPoint that seems to have closed. Just a second. Just going to open that again. Not sure why that happened. Let's see. There we go. Okay. And I think we're back. Yeah, okay. So now we get back to analytics and we're actually going to look for some insights based on all that, all those predictions that were made by that model. So back in analytics, we're now just going to look at a particular match. Okay, so here I already created a project here that looks at one particular match, Liverpool against Manchester. The output or the returning result was 2 against 2. Okay, so what we can also do is we have all those shots and we can plot them on a football pitch. So I've done that here. And by the way, these blue ones, those are the goals. Okay. Now we could already have done that even without the XG model. But what is the new thing here? What's the special thing is we also have the XG value for all of those shots. And that's indicated by the size of the circle. So the bigger the size of the circle, the bigger that opportunity was. Right? So we have also, for example, a very big opportunity here that didn't become a goal. You see that, right? Now let's take one example here of a shot that did become a goal. Just hovering over it. This has an XG of 0.08. So let's see who made that shot. This was Kevin De Bruyne. Okay, and let's have a look at a video of that shot.
Dream start for Manchester City.
Yeah, so beautiful shot from decent distance, I have to say, and very nice finish by Kevin De Bruyne. Now, at this point, you may think, okay, that's interesting. So we have this XG value for any shot, but what can we do with it, right? Because by the time you can calculate what the XG for a shot is, you're too late to do anything with it, right? You cannot use it to place a bet, right? What's the chance that Kevin will score this goal? You're too late already. That's also not how we're going to use the XG. We use XG more actually in hindsight what was the quality of the opportunity? What was the chance of scoring that shot? Okay. And the interesting thing comes now when we look at many shots. So for example, if we look at all of the shots for each of these teams and we summarize the XG value of all of them, we really get a metric for how big of a chance, how many chances did they create in total. So you see, for example, that Liverpool, they were expected that from all of the chances they created, they expected to only score half a goal. Of course, that doesn't exist, right? And Manchester City was expected to score about 1 goal. And we also see that both teams actually did really well from the opportunities that they had, because they scored 2 and 2, much higher than that, let's say 0.43 and 0.97. So it starts to get more interesting now. Now we look at, let's say, more shots at the same time. Now let's have a look how we can use it to analyze the performance of players. Okay, so I'm going to just go here to one particular player. Yeah, there he is. So this is Sterling. And this is a striker of Manchester City. We can see now that in the last season, he shot non-penalty shots 54 times. He made 11 goals from those shots. Those are basic stats, right? That's nothing too special. Now here it gets more interesting, because according to the XG model, we can see that the average player would have been expected to score from the opportunities, let's say the position that he was in, the fact that it was a kick and from a corner or from a counter, etc. He was expected to score 9.75. So he's slightly overperforming, but it's all good, right? Because what's the special thing is, of course, is that he creates that XG in the first place. And we see that if we get here closer to the goal, he is able to get into the zone, right? That's the reason he gets that high XG value. Now let's take one more player. And this all looks very different. This again, that same player from before, Kevin De Bruyne. He shot in all of season 78 times at the goal. He scored 15 of those shots. And now the really interesting thing, according to our XG model, given the circumstances of all of those shots, the average player would have been expected to score only about 6 of them, right? But he scored 15. So he's massively overperforming with 9 goals, right? He's doing really, really well. And you can see here, if you zoom in, especially those shots that are a little bit further away, he's really good at that, right? That's kind of his trademark. And he scores from them where the average player wouldn't have been able to do that. So let's say Mr. Pep Guardiola, he's done that for all of his players, and he sees on the offensive side that things are looking really, really good, and he doesn't really have any point for improvement. So now, what can we do on the defensive side? What can we do on the goalkeeping in particular using that XG model? So if we want to use the XG model for that as well, we need to do a little bit more, because if you think about it, this XG model until now, it only had it took into account the factors of let's say of the game right until the point before the ball left the player's foot, right? And if you think about it, that's not really fair to evaluate goalkeeping, because shot that goes into the top corner is much more likely to be difficult, right, for the goalkeeper than one that goes straight through the middle. So if you want to take that into account as well, we basically have to build a new version of this model, a new type. And I've already done this. I've called this the expected goals on target model. And it's basically the same as the XG model, but now we also include the position that the ball is headed into the goal, right? Even if it doesn't become a goal, we kind of, we say, okay, it went to the top corner, it went through the middle, right? And I've already done this. We're not going to show the notebook now, but you get the idea. It's basically the same thing as the previous notebook, but just including, let's say, that extra coordinate inside of the goal. So let's go back to analytics. And now we can visualize, for example, all of those shots that were fired at Manchester City's goal in one season. So here we see 141 shots fired at the goal. And let me just take one particular shot here. This shot has an XG on target value of 0.49. So what does that mean? That the average keeper, well, just any average keeper, given the circumstances of this shot, like the distance, was it a header or a kick, where was it aimed in the goal, the average keeper would have been expected to let it become a goal in about 50% of the cases. Okay, so let's have a look actually at that shot.
Kane's ahead of him. Son has seen Harry Kane. That's a massive block from Ederson.
Yeah, so very good block by the goalkeeper. So again, the interesting thing comes if we look at many shots, okay, just like with the other model, because what can we learn now? Of those 141 shots at the goal, 25 became goals. Now, Pep Guardiola will probably say that's really, really good because it's the lowest goals against for any team. So, hey, we're doing really good on the goalkeeping side. But it becomes different when we look at our model's prediction, because what does this model represent? This model represents of all of those shots that were fired at Manchester City's goal, if an average goalkeeper were, let's say, in the goal, and taken into consideration all the, let's say, the difficulty of the shots, or the relative ease or difficulty of all of those shots, the average keeper would have let 21.5 of those become a goal. I hope that makes sense. Yet 25 became goals. So there's a gap of about 3 or a little bit more that we could be performing better as Manchester City. So yes, at first sight, 25 looks really good, but it could have been better. Okay, so that's our big takeaway for Mr. Guardiola. And he can see that he could possibly improve there. So just to illustrate it a little bit more, if we take another team, this is a Wolverhampton Wanderers. This team ended much lower in the league, but actually on the goalkeeping side, they did really, really well, because look at this. They had 298 shots fired at the goal, meant much more. 33 of those became goals. But if we ask our XG on target model how many were expected to become goals, it says 48. So the goalkeeper actually stopped 15 more than he would reasonably have been expected to do, right? So that's how big of an impact the goalkeeping can have. So yeah, that's a big insight for Pep Guardiola. Okay. Well, now we go to wrapping up. I got one more little insight I wanted to share with you. It has nothing to do with Manchester City. I was just really interested to know what was the most amazing goal, what was the most improbable goal actually of the season. And the way I did that is just look through the data and find the goal with the lowest expected goals value, right? And that is this one. So that's a shot here by Wissa. You see him here on the bottom right. And this has an XG of only 0.015. So 1.5% chance, according to the model, that this could become a goal. Now let's see what happens here.
Every Evertonian face.
I think that's truly an unbelievable shot. I'm not sure it even was his intention to make a direct goal here, but we'll never know, I guess. So yeah, I think it's time for me to wrap up. I hope you got a good impression of how we can use analytics and machine learning in football, in soccer, in sports in general. And a lot of these, of this mechanism that you saw, so the interaction between the database, the in-database machine learning and analytics, can be applied to other problems in sport and also in business. So I hope you got your own ideas while you were watching this of how you could be applying that yourself.
Jeroen, thank you.
Heavy. Yeah.
A fantastic presentation, my friend. Really appreciate that. Yeah, we've kind of run out of time for Q&A, as we suspected we would, because you've got so much great content. As you said at the start, if you want to hear more of his incredible presentations, check out his YouTube link there. Like I say, and like he said, go and have a go with it. Go and do the live labs, have a go, and learn about, you know, XG models. There are a few questions, Jeroen, in the Q&A. I'm hoping you can maybe do that offline as the next speaker is talking. But the one that asked if Pep Guardiola's attending next time, Jeroen, I would be loving you if you could get maybe Pep, or I'm Eddie Howe for Newcastle. So, you know, if you can get one of them to attend next time, we would absolutely love that.
Should be no problem.
Thank you. And thank you again.
Bye, everyone. Thanks. Bye.